Okay, we are in chapter 3, and let's see if we can add these vectors together using Autodesk Inventor. So we'll go into English units and hit the standard part, hit create. The reason why we're using English units is because the first vector is 100 inches. So once it comes up here, we'll go over here to sketch and create a two-dimensional sketch. Let's select the XY plane. After all, these are normally in the XY directions. So we'll select the line. I wish we could select an arrow, but instead we'll just have to get the lines drawn and imagine that they are arrows. Before you click the second time out here, let's just go ahead and type in 100. That way it puts the dimension on there automatically. Then we can zoom back to zoom all, or we can just say front like this, get the whole thing in there. We can hit escape, move this thing down here. And now we have the first vector done. It's not completely defined because we need to have the angle set to 30 degrees. Looks like I didn't do that one right. So we'll see if it'll let me do this axis. Doesn't look like it's going to let me select that axis. Okay. So one of the things we'll notice here for each one of these, excuse me, is you probably need to have a construction line drawn here for reference. And we can just make it an arbitrary length. Let's say, I don't know, like 20 units long, like that. And let's make another one up here. So let's hit escape, leave it on the construction tool, and we'll also make this one horizontal, and we'll also make it, whoa, get horizontal 20 as well. That way those are fully defined as soon as we get this angle defined. Now if we go from this reference line to this one, now we can set it up. Gosh, I came really close there. I don't see how I got that close. Now you look down here and everything's fully defined, and that's primarily because we set the lengths of these reference lines. The reason why I did this is because these dotted lines right here represent the x-axis that it talks about right here. So the next thing you do is use that reference line and imagine that you're going to be 60 degrees away from here for vector B. All right, so let's set that up. And again, we don't have to dimension afterwards. We can dimension before we do the second click, like that, and then hit escape, dimension, go right here. And I've noticed this happening before. Okay, there it goes. Clicking here and clicking there. And we have to put this at 60. And I see what my problem is now. This one should not be a construction line. That should be a visible line right there. Okay, so now we got two vectors down. And I might come back in a little bit and just show you how we could maybe color code these things. Maybe. But we don't need this many digits past the decimal, so we do want to adjust those by going to Tools, Document Properties, Units, and then let's set it down to just 0 past the decimal, also for the angle as well. That makes things look a little bit cleaner as we go to the next one. And so we set up another x-axis, which will just be 20 units long. We'll see sketch, and then we're still on construction line. Go here, horizontal, tap in 20, and we're done. Now let's get this construction line off this time. Let's see what that is there. There's the center point. I don't think we need to do that just yet. All right, now we need something 80 that's at 120. So it's going to be beyond this vertical line. So I guess we could escape, move this down or over like this, because that's not really relevant to what we're trying to do. And so then we get this one. And so this would be 0, 90, around 120 is this direction. Before you hit the second click, just type in 80 and hit escape, go to dimension. Relative to this axis, and we're going to be careful not to hit the midpoint out here and over here. We want this to be 120. I guess I did pretty good on getting those accurate. All right, let's do one more reference line. 20 degrees, or 20 inches rather. You know what I'm going to do to clean up my diagram a little bit is just put it out there at 50, and it's going to be one of those unknowns. And I'm going to go back and delete the 20, just so it cleans this up so we only have magnitude and direction. And then you might wonder, well, how do we make sure these things are known? Then we can just use this first one down here as a reference. So what we can do is say, I want all of these to be equal. So you want this one to be 20 inches, and this one, and this one, and that one. And then now it should say zero. Let's see what happened there. Maybe I didn't click it enough. So this one and this one. Oh, wait. It must have thought that I was doing those last two together. So when in doubt, you hit Control Z until they all kind of come back to 20 like that. Let's zoom back in again. And let's just see if this control goes away after I do the second click. Yeah, it looks like it did. So we also want to click this one and the next one. And then I think we want to do this one and the next one. So you can't really click them all together, it appears. I thought that we could. Maybe if you did shift click or something like that, it might work. Now this is going to be below the horizontal, below the negative x-axis. So we're going to draw that one as such, making sure construction line is off. Going down like this, a distance of 200. All right, and then we'll do escape dimension from here, whoa, all the way over to here. That doesn't look right, or does it? Let's see. I guess really what we want to do this thing from there all the way over to here. Let me see if that's really what we want. If we typed in 210, does that make sense? No, there's something not right about what we're doing here. So for some reason, it didn't get all the way over there. Let's try that again, Control Z. And we want to go from here all the way over to here. But for some reason, it's a little bit confused about that. Doesn't let you go all the way down here. So what can we do instead of that? Well, I guess we could do something like this. Click in here and we can go 210 minus 180 because it can do the math. And then we find out that that's 30 degrees. If you could find out a way to get that angle to go all the way around there, that would be better from here all the way over there. But for me, it wasn't working. Now if I go this direction here, I think it'll do that, 150, but I really want it on the other side. But it just will not let me do that. Okay, but we can do the math, right? 180 would be here, and then 210 minus 180 gives me this one. Should be fully constrained, as it is, you see here. And so now all we need right now is the resultant. Now, let's see if we can go in there and do the resultant. So the resultant of a vector R starts where you started, in other words, at the origin, and it ends where you end. So it's got to be right there. You'll notice it's still going to be fully defined after this. Everything is black like this. And that's because the resultant is actually known, and you can use the component form of the vector addition to figure out what those components are, the X and Y components. You could go like this, for example, right here and right here to get the X component. That would be 52. Over here, you can get the Y component. But what we really want is actually this right here. Now, to get the magnitude of it, you click here and you just come a little bit off. And it looks like there's nothing, but then you see it right there. All right, it's going to say, do you want to set this as driven? And you want to say accept. Because all of these vectors components, or the magnitude and directions rather, define what this magnitude is going to be. So it's okay to do that. Now, the other thing that we know for, or want to know for part number 2 is to come over here and go from this resultant all the way back over to the positive x-axis. That didn't work, so I'm going to zoom way in and try that again. And go right here to right there, and you can see how to get that angle there. You do want to hit accept again because these two are going to be overdriven because they're actually the ones that we are trying to measure. So I guess we could use the inspection tool instead, but it's better to display them on here. Let me pause the video and see if we can find a way to color code these just out of curiosity. So let me pause that. Now, if I had these letters colored, what I could do is right click on them and then say that maybe a vector is red. So then I go to properties and select red. And then I click on this one, make this next one green. So again, we're going to right click on it and say properties. And we'll go over here to green. I'm just showing you how you can annotate things. And I don't know if we can change the line thickness. So let's see if there's anything so we can make it, oh, here it is. Okay. So we could make it really thick, like 0.02, and then make this one blue and apply. It doesn't look like it's any thicker though. So that might be just misleading. I did see something in the comments that this was not really a setting. I'm gonna go extreme here, red, green, blue, and then we'll go like cyan, apply, and it went back to the other one. It does look like it's a little thicker. It's not that important that we get the thickness. I just thought it would be interesting to kind of show you how you can document changes. Let's put this one as magenta instead. And then this one right here, we might just make this one a little bit thicker or a lot thicker so it kind of stands out. Let's make it as thick as it can get here. That one right there. And let's see. I guess we'll just leave it black so we know that that is the resultant. We can also do things like, put an arrowhead on there, but it's not really very easy to do here. You'd have to kind of draw an arrow over here. But you could also do things like put a point out here, maybe to indicate where the arrow should be. So we're using the so-called tip-to-tail method that we use in physics and engineering. Now this one starts here and it goes back this way. So the resultant actually goes back over this way. So let me hit Control Z because I've left one out there in space. Oh, I can just barely see that one also. Anyway, the tail is here, tip is there, all the way around. It's like a treasure hunt. And then this is the shortcut. The resultant here is the shortcut. There's a magnitude, there's direction. So I guess I actually did that one for you. I guess I could change the numbers so that you would see how to do that there. But it does look like yet another example. I hope this video helps get you through this exercise. You'll be doing some other properties, such as going to inspect regional properties and measuring the area of various shapes down here. And also be measuring the weight of an extruded piece here. All right, so I hope this helps, and I'll see you in the next video.